So, morning everybody. This video is part of the Scientific Python programming course at the University of Bremen. My name is Bálint Aradi, and I am the instructor of this course. And in this video, I would like to tell you a little bit about the goals of this course, and we will also start immediately with the first topic, which are some Unix basics. In the last video, or in the pre-video, the video before the course, I have shown you how to install Linux in a virtual box, and I would like now to start your Linux installation, this virtual box, and we will do everything in this virtual box. And using this virtual box, I would like to show you, if you start a virtual box, you should see this kind of Ubuntu operating system. And first of all, I would like to show you where you find the slides and the exercises to this course. So basically whatever I will show you as a slide during the course, or whenever we are talking about the exercise, you can find them on the website of the course. And you just basically, in order to do that, start the browser here with the web browser icon, and then you go to www.bccmet.unibremen.de. This is the Bremen Center for Computational Material Science. When I'm working I'm part of the CMS group. You go to the CMS group, and then you go, the simplest way is you go to teaching or to people, sorry, and then you just choose my name. And then basically here you have the scientific programming course. I'm offering Fortran and Python. We are talking now about the Python course, so we are talking about this course. You just go to the teaching material Python and you click on that, and you will see all the slides. The videos will be offered on a different way, but since you are seeing this video, you have already found the videos. But you find here all the slides, right? So you can basically, today's topics in the instruction slides, which you can immediately download if you want. Usually I'm putting a date next to that. Is the date when I last time modified the slides, so that basically you can know, okay, if you downloaded it last week, then you should download it again, because I made some minor changes. You can download the slides now, because we want to go through that. And the first thing you see here, that the slides in this Ubuntu opens within, or a PDF document opens within Firefox, within the browser. I'm not that big fan of that, so I would like to change that. So I will just show you the trick how to change it if you don't like it either. You can just go to the menu and then preferences in Firefox, and then you are looking for the content. There is a setting for the content, and then here basically for the portable document format, it's a preview in Firefox, and instead of that I will just say use document viewer, which is Evans on that machine. So that's basically all. Now we are going back, and if you are downloading the slides again, it should open in an external window, which indeed happened, and then basically we can even click Firefox, and we can just have a look at the window. Okay, good. So this is how we will look at the slides, and I will just make it a little bit bigger, then you can see that. And then basically, as it says, we will cover Unix basics. And again here, down there, you find once more the link. So if you save it, you can find this. If you open the document, you can also find all the other slides exactly at this URL. So basically the topic of this video and this today's course is just some general information about what we are doing, and then we will start with the basic commands under Linux. Now let's have a look at that. So what is scientific programming at all? It's not that easy to give a definition, but basically I came up with a definition that the scientific programming for me is basically nothing else that you implement some numerical algorithm in a given programming language. The programming language can any programming language, but the main important point is that we are implementing this numerical algorithm in order to solve some scientific problem. The basic steps which you have to do during this process are just shown here. First of all, very important, we are talking about science. First, you make a model. You know, as a scientist, that it's not that easy to describe reality with all this complexity, so you always have to simplify. And this simplification is basically making a model. This is the process of making a model. Once you have the model, so you know what are the equations you have to solve, then you have to program them. In order to program them, you have to choose the algorithm how to solve them, right? Here you can have different kind of priorities. And I would say that the first priority should be correctness, of course. I mean, the algorithm should exactly solve the thing which you want to solve and give you the right results. It's very important it's numerically stable. It's very important that this discretization is done properly. That means I won't go into the details at the moment because that's not topic of this course, but error estimation, it's a very, very important topic. Then it's not bad if the algorithm which you implement is flexible, so you can apply it to a broader range of problems as just the one you are at the moment interested in. And finally, of course, it's very important, or it could be important, that the algorithm you are using is efficient, either in memory or speed, or in scaling or whatever. Choosing the right numerical algorithm is a very interesting point, and if you want to have some fun reading, you can look up just on this link with some famous numerical disasters. It can show you what can happen if you do not choose the numerical algorithm, the numerical representation correctly. Like, for example, basically just the first flight of the Ariane 5 rocket, which basically was a disaster. So just have a read at that if you wish. This is not part of this course. In this course, but I want to concentrate is basically what happens after this point. And I want to concentrate on those points. So starting from planning the program structure. What does it mean? You want to have you know what to implement, but you want to start to have a plan. Okay, which pieces I will want to write. I mean, you cannot write everything at once, so you want to chop it into pieces. It's very important to define how the pieces are talking to each other, right? So we would like to have small, independent, mostly independent parts which are just talking to each other through some well-defined interfaces. Then once we have the planning, of course, it's important to code it really up in a proper way as according to the state of the art of informatics. And that's the point where many people stop. But this is exactly not the point where you stop, because you only made maybe 1/3 of the work or even less. Because the real work just starts now, and that is, for example, testing your implementation, absolutely important. So without a test system, no scientific program should be ever delivered without a proper test system. Because how do you know that the thing still works? Or if you change something later in a very complex program, how do you know you didn't break something which was working before? So an automatic testing framework is important, and we will talk about that and cover that in this course. Documenting your code is very important. Why? Because you want to understand also in 2 years, when you didn't work on the project, what did you do? And therefore, documentation is very important. So this is developer documentation, but also, of course, user documentation. You want to make sure that also somebody else can use your code, not just you on your own. And of course, last but not least, a very important point: it would be good to have a code which you can extend and reuse, because then the time which you invested to create that code was basically well invested. So if other people can also use your code, reuse your code, then this is basically the best thing which can happen to a scientific programming project, in my opinion. Okay. So in more detail, the content of this course, we will have some introduction into Unix and Linux. That's the topic of this video. Then we will go to Python, look at the basic data types, the control structure, and how to handle input and output, functions, modules, so basically how to make different kinds of units. We will also cover probably the basics of object-oriented programming a little bit. We will talk about graphical output and plotting, which is very important for scientific things. And this is basically, let's say, the programming part, the programming knowledge of the course. But we want to go beyond that, because my purpose is not just to show you how to program in Python, but I would like to give you a workflow which is helpful for scientific programming, or in programming in general, developing larger projects, especially developing projects together with others through collaboration. And therefore, we will cover very extensively version control, so how to make via Git, how to version your project history, and how to ease cooperative development through this version control software. We will talk, as I said, it's very important about testing, so therefore we will talk about unit testing, and of course about documentation, source code documentation, and also we will talk about a little bit how you can measure the performance of your code and maybe speed it up, optimize it. So this is the topic of profiling and code optimization. And last but not least, if time remains, we will probably talk a little bit also about parallel programming at the end. Now, what kind of literature you can use in order to follow this course? Of course, you have the slides. That's the straightforward way to do. Additional to the slides, I would say whatever you find about Python. I mean, Python is a programming language which is very, very popular. Literature, internet, Stack Overflow, various kinds of mailing lists, websites. So there's a lot of things. So whatever you find can be useful. However, please, very important note right now. It would be good if you would, when you solve an exercise, you would use the constructs which were shown in the course, because it's didactically important that you learn to use those constructs. Sometimes those constructs are not the best solution or not the simplest solution, but I don't think it helps you a lot if you basically solve an exercise with an algorithm, which is a very cool solution, which you found somewhere in the internet, but you don't understand. So basically my point is, wherever you look up something in the internet and outside of this course, it's perfect, but make sure that you understand that the thing what you wrote works, and especially that you understand why it works and how it works. Okay, so that's very important that you always understand the background, whatever you wrote. Okay, so let's have a look on Unix. Unix in general, I don't want to tell you much about the history. It's a very old operating system, kind of operating system, family of operating systems. If you ask me, this is basically the best operating system so far, but I may be, of course, biased. I'm working under Unix basically all the time. It was created in 1969 in AT&T Bell Labs, and it was first written in assembler, but then they made a very, very important step. Basically 3 years later it was rewritten in C, and from that point on Unix was portable, so it was running on one machine. It could be, if it served as an operating system on one machine, it could be very easily transferred to a completely different kind of machine as long as that machine offered a C compiler. It became then with the time very, very popular in academics, and basically high performance computer centers used during the time, and also right now basically almost all high performance supercomputing systems are driven by some kind of Unix operating system. In 1991, Linus Torvalds started with a special Unix kind operating system, which was the Linux for the i386 PCs. And then basically this operating system became very, very popular, and nowadays basically one of the most popular systems also on desktop computers. And therefore we will cover Linux. Linux is just one flavor of Unix, so there are different kind of Unixes. So Linux is just one flavor, but for example you have also BSD type of family, FreeBSD, NetBSD, OpenBSD, and you have even a few commercial one. And basically just a few years ago also Mac OS X changed to a Unix derivative, to the Darwin derivative of the BSD Unix. So basically also Mac OS X is based on a Unix kind of operating system. And Windows not yet. However, Windows has just since a few years this Windows Linux subsystem where you can start also a Linux within Windows. So basically it basically doesn't matter what kind of operating systems you use. Even Android is based on Linux. So basically it doesn't matter what kind of operating system nowadays you use, you are almost at least below the hood. You have some kind of Unix operating system. Okay, why is Unix so popular? Because it's a very nice modular operating system where you can combine various pieces and with each other. A very characteristic of Unix is the number of options. Sometimes it's good, sometimes it's bad, especially at the beginning. You have if you want to do a certain task, there are usually different kind of tools and different kind of ways how you can achieve that. And at the beginning that can be difficult, but then later if you get more and more professional, that becomes an advantage. It's very communication and network oriented, and it has a multitasking and multi-user operating system by design from the very, very beginning. And as I said, and that's very important, and for me one of the appeals of the operating system that you can combine things very easily, small tools very easily with each other. Okay. If you want to communicate with your operating system, there are two different ways how you can do that. I mean, at the moment we are doing it via the graphical user interface by clicking on various icons, and this is a very easy way to start and very intuitive way to start. But this is not the only way, and the way we prefer and we use during these semesters is the second one, where we are talking with the operating system with the help of commands which we were typing. So we are basically talking to the operating system through the command line interfaces. The nice thing with that is that you are more closer to the operating system. You can probably more understand what happens. The disadvantage, of course, is you need a little bit more knowledge. But in this video, I will show you the very basic knowledge on starting on Unix, and that should be already enough to cover most of the needs which we will have during the semester. It's also, if you have a command line window, it's very often to formulate tasks sometimes which are repeated. It has to be done several times. If you have a graphical user interface, it's usually a little bit more complicated. We don't need too much commands, so don't be afraid. We will only have one video, one lecture about Unix, and then we will start with Python. So we really only need the very basics. So I said we will access Unix via the shell. What does it mean? The shell is basically the interface between you and the machine, and you are basically typing in some commands. These commands are basically received by the shell, then interpreted. That means the shell tries to find out what you want it to do, and then the command is executed. So basically the shell does what you asked for, and then sometimes you get a confirmation. For example, especially under Unix, if it failed, you get an error message. Usually if the command could execute what you were asking for, then maybe there are no response at all. Also for shell, how you communicate with the operating system on the low level, the commands, there are various choices. I just here item. I had a small item. We will use bash because this is maybe the most widespread command line interface shell what you can find. There are also other choices, and once you are good enough in bash, you can just look around. Maybe there are some other different shells which are you like more, and then you can use that later. As I said, unfortunately, the shell command syntax and the shell programming is slightly different between the shells. Each one has advantages and disadvantages. But most of the time, we will use programs which are independent of the shell. So basically, the choice of the shell is not that important. We will just cover a few, as I said, a few things which are shell dependent. So let us start together. Let's enter commands. In order to enter commands, we would start this terminal. It's called xterminal, lxterminal, basically a command window. And that you can do by going with the mouse and clicking on this lxterminal icon. And then basically what you will see that a command line window opened. And in this command line window, you can enter command. This thing, what is here, this first line, is the so-called prompt. So basically the shell is showing you something, and then here the cursor is, and if you type something like ls, we will in a second see what it does, then you can enter, and then you can enter it, and if you hit the enter key, then basically the command is received, interpreted, and then the result is written out. The ls command makes basically lists the files and the directories in a certain place, and then you see that you have a folder, desktop, and documents, downloads, and so on in your current directory. So this is basically how the shell really works. Okay. Now the question is what kind of command we should enter. So this is, oh, by the way, the thing which I'm showing you here is basically something you can immediately follow. So whenever I switch to the shell window and execute something, you could stop the video or do it yourself, and then so that you can immediately exercise those things. So basically do not wait until the end of the video, do the commands which I'm showing you immediately so that you get trained in these commands. Okay, good. What kind of shell commands we will learn? Usually we will, if you use shell, very often you are manipulating files. So we will learn a few commands how to manipulate files, like copying things, or how to edit files, or how to extract some information from a file. Very often use the shell just to start other programs and applications. We will see an example for that soon. And very often you are using the shell to interact with the operating system, like for example changing permissions for a file. If you want to make sure that a certain file only you can read, then you can change the appropriate permissions of the file using this shell command. Okay, good. So let's first start with the files. So working with files, what do you have to know? How are the files organized? The files, as shown in this figure, the files are organized in a kind of tree. So basically, just look at this figure here. The files are organized in a tree. What does it mean? Every file you ever store on the Unix systems is somewhere within a tree. The tree starts in one point. This is the root of the tree, if you want to put this way. I put it in the upper part. So think about it as an inverted tree, but basically the tree has a root. This is the root directory, and from this root you have basically nodes, and every node can have subnodes and so on and so on. And whatever you do, whenever you create a file, this file can be found somewhere in this tree. The levels in the tree are separated by slashes, and also the root directory is indicated by a slash. Not backslash like in Windows, but it's a slash. And as I said, the various components are also separated by slash. For example, if I'm just putting a USB Kingston's USB stick in my machine, it will appear under /media/Aradi/Kingston, for example. And the path to a file is basically nothing else, just a recipe, how it can be reached from root. So basically starting from root, you would have to go to the node, to that folder media. Then in the folder media, you would have to go to this folder, and in this folder, you would have to go to this folder. In contrast to Windows, if you are used to Windows, there are no drive letters in Unix. Even mobile devices, when you insert them, they are just appearing somewhere in the tree under a special directory. Okay, so really everything is in one tree. For example, as for external drives, they're usually typically under Linux and Ubuntu for sure, appearing under /media/your username, and then in a directory named after the thing which you just attached. And this is this process of attaching something and then create a directory in a tree which represents that device. It's called mounting. And if you just basically want to deattach it, then this is the so-called unmounting, just that you know what is this about. The important directories for us, which we are interested in, is mostly our home directory. This is the space where you are supposed to store your things, your data, for example, your programs which you will write. Then there are interesting directories where you can find the programs which we can execute. Those are typically those directories listed here. And then there is the so-called temporary directory, as in /tmp usually, where processes can store temporary data, but this temporary data, as the name indicates, if you reboot the machine, the data is gone. So basically, this is not the place where you should store files which you want to keep. But if you want to store a small file which you do not want to keep, just create for a few minutes, you could in theory also use that directory, and many processes, many programs will use that directory automatically. Now, we said everything is a tree. How do we know where we are in the tree? And there are many ways to have a look at that. First of all, if you look at this window here, at the prompt, then in the prompt you have first your username, then the name of the machine. We call this machine SciPro. And then we have here a tilde and a $. And the $, is just a separator which separates this information from the command which you will type. But this tilde is basically the directory where we are at the moment. And tilde is basically an abbreviation for your home directory. If you want to know what is the directory where you are, where is it in the tree, then you can just type the command pwd, so print working directory. And then you see that basically we are in our home directory, which is in the tree. Starting from the root node, you have to go to the home folder, and in the home folder you have to enter the folder Aradi. In my case, this is my username, so this is typically your username, and that's your home folder. And this is the abbreviation for your home folder. So wherever you see tilde in a path, then basically you can substitute it immediately with the path which leads to your home directory. But this is a nice abbreviation. Now, if you would change to a directory, how can we change a directory? This is the command cd. This is the abbreviation for change directory. And you can change to a directory by entering its name. So let us have a look. For example, with ls, I can list the files. We will handle this command a little bit more in detail, but basically we can see that if I type ls, I get various names. And because those names are blue, that means those are directories. And then if I wanted to enter the folder documents, then I would say cd documents, and then I hit enter, and then you see that the prompt immediately changed. It indicates now that you are in the folder, in the documents subfolder of your home folder. So tilde is your home folder, and we are in the documents subfolder, right? And that's it. I can say ls. If you want to go upwards, or first let's have a check where we are. We can use this pwd command, print working directory, hitting enter, and it tells us, okay, we went one level down and we are now in the document subfolder of the folder Aradi, which is a folder of the folder home, and which is a subfolder of /. So basically we are /home. And you could have entered this directory also by basically entering the full name. So let's go back, and this is also one thing I want to show you. If you say cd ... we will show in a second why, it leads you to the next directory. So basically it goes one level up. So if I say cd ... in the documents folder, then I will go just one folder higher, and I am in my home folder again, /home Aradi. And here you also see that basically here the prompt shows that only tilde, so you are in your home folder again. Okay. There's also another way to enter the documents folder, and this is the way we did. We were in the home folder and we indicated the name of the folder we want to enter. This is the so-called relative path, which means you are saying relative to the positions where I am now, how can I enter the folder I want to go into, which means just go in the subfolder documents. On the other hand, if I want to go somewhere else, I can always also specify the so-called absolute path, which means starting from the root point, from the root directory, what is the way to access the directory where I want to go to. So in this case, I would say cd /home /aradi /documents. Okay, and then I would just hit enter. And then I am in the same folder again, but now I specified the absolute path, so basically from the beginning up down to the documents folder. Similarly, if I want to go to my home folder, ... was relative, which means go one level up from the position where I am, but instead of that I could have written cd /home /aradi, then I would have landed in the same folder. Or if you want to abbreviate it, it's even easier. I could have said cd tilde, sorry, which means that basically this is the abbreviation, as we already discussed, the abbreviation for your home folder. Okay, there we go. Good. So here in the slides you see the same, so you can also, if it was too fast for you, you can just have a look at that. Now we want to create a directory and then also delete a directory. The command to create a directory is mkdir, like make directory, and just you have to basically add the directory name, the name of the subdirectory you want to create. If you want to remove a directory, it's the command rmdir, like remove directory, and again you have to specify the directory name. Again, if you specify a directory name, it can be relative or absolute, so either relative to the position where you are or absolutely starting from the root folder going down to the right point. So let's have a quick test for that. We are now in our home folder. Actually, if you just type only cd without any arguments, then you would also always end up in your home folder. So this is basically equivalent. CD without any arguments is equivalent to cd tilde. It's the same, nothing changes. Now let's create a test folder. We are saying mkdir test, so we are creating a test folder. No error message appeared, so it seems that it has been created. And with the command ls, which is, as I said, the command to list files, you can see that basically now a new folder, a test folder appeared here. So basically we created that directory. We can even enter that directory. So we say cd test, and then, okay, there's nothing here, it's empty, but we could enter, and then with cd ... we could go one level higher again. Then we are again in the home folder, and exactly this tilde is, as always, shows you here that you are in the home folder, right? Okay. And then if I want to delete the directory, I'm saying rmdir test, so delete the test directory, and I'm saying enter, hitting enter, and that's it. Okay, with rmdir you can only delete the directory if the directory is empty, if it contains files. If it contains files, it's you have to use a different command, which I will show you, or you have first to delete the files from the directory, and then you can delete it. Okay. Now let's go to the details of the ls command. So as I said, you can list content of a file and the directory with ls. If you just say ls, it shows you everything in the local directory. But if you want to list a subdirectory, you can either change the subdirectory and make ls as we did before, or you can say ls documents and then it will list you the subdirectory documents. Actually, it's very boring at the moment because there are not many files around. But for example, if you would list the downloads folder, then you see that here we have, for example, at least one file, exactly the file which contains the slides which we are looking at. Again, with ls, if you want to tell what to list, you can also even give an absolute path. So if you want to say ls home Aradi downloads, that would be also possible. Okay. One slight remark: you may be wondering how can I type the paths of the files like /home /aradi /downloads so fast. I can tell you the trick, and the trick is to use the tab button, the tabulator button. This is on the left hand side. The second one from above, it's a tab button, and it can use to expand path information under Unix, under Linux. So for example, if I say / and then h and I'm taking tab, it immediately expands to home, because home is the only directory, the only subdirectory of the root directory which starts with h. So let's first list the root directory. You see I have many things here, but basically home is the only directory which starts with h. So basically if I'm typing, let's say just / and then I'm pushing the tab button, then nothing happens because my choice is not unique. If I push the tab button once more, so twice, it shows you what kind of options I have, and I see one of the options is the directory home. So I'm just typing h and I'm pushing the tab button again, and voila, it is expanded. Then I want to go to the folder of my username. I'm the only user of that machine starting with A, so I will just type an A and basically push the tab button, and then it's already expanded. And we wanted to have a look on the downloads folder, so I will just push D and then tab twice, because after the first nothing happens because it's not unique. You see that there are 3 directories which starts with the capital letter D, and we want to look at downloads, and DOW would be basically the unique part, and then if I'm pushing tab, basically it expands, and that's it. So basically, if you are using Unix and your tabulator button is not used as much as the white space button, then you do something wrong, because the tab can always help you to expand things automatically. That's a very, very handy feature and can help you spare a lot of typing, and also to avoid a lot of mistakes by mistyping long paths or whatever is needed. Okay, but let's go back. We want to have a little bit more detail, have a look at more in detail on the ls command. And then basically we want to pass some arguments to the commands to modify the behavior of the ls commands. And there are 2 different kind of arguments, the so-called optional ones. They typically start with a minus or a minus minus. We will see immediately an example. And the so-called positional arguments. Those are usually usually file names which you have to type. So for example, when we say ls download, then basically the string download is a position argument which just specifies a file, a directory which should be listed. But you see now I was mistyping it because I didn't use the tabulator to expand the file name, and you see it's basically wrong. It says also the error message immediately came, there is no such file directory. So let's try it again. Say lsdow and then push the tab, and yes, you see I have forgotten to add the S symbols. It's called downloads, and then it works again. And then basically downloads, this thing is a position arguments which specify on which file the command should act. Good. So let's prepare the playground where we want to test our stuff. So basically let's again make a test directory, mkdir_test. And then let's change to that directory, cd test. Again, you say cd space, and then you push small t and then tabulator, then it will be expanded, and then enter. ls, there's nothing here. We will just create a few dummy files with a touch command. The touch command is not that important. It will create empty files, and then basically as we've written here, you should create those three files, file1.dat, file2.dat, and hidden. If you want to copy paste, just select in the slide what you want to type. You can make Ctrl+C for copying, and here in order to insert that into the window, you need Ctrl+Shift+C V. So that you should also do the shift, push the shift button. Okay, and then now if you make an ls, you see we were creating three files, file1.dat, file2.dat, and .hidden, but apparently if do ls we see only two of them. And the reason, as we will learn later, is because it's a called hidden file, and not because the name is hidden, but because it starts with a dot. And every file starting with a dot is usually not shown if you just make an ls, a normal ls or something similar. Or okay, good. Now we want to have a little bit more information. So we will say ls, then we see the files. We will make the options -l for the so-called long listing and the -h for the human readable form. And you immediately see that the way the ls command works has been changed. It still shows this, the same file, right? So there's no difference on what it was applied. But the information which it does, how it does the listing changed, because now we see a lot of additional information. We could also add, for example, a position argument. For example, we could say ls -l -h, and those are the options, and then add the position argument file1.dat. You have seen again, I was using the tab button to expand the file name, and then I would get the information as before, but only applied on the file1.dat, so only for this file. Okay, good. So this is basically the way how you can supply positional and optional and position arguments. Know what kind of arguments you can use for the ls command. There are a lot. We will not cover all of them, just a few. For example, this -l command is very, very useful, and this is stays for long listing, and you get additional information about the file. Here at the end you have the file name as before, but here before that there is a lot of informations. Here you have something, some cryptic information which has to do with the access rights, who can read the file, who can write the file. We will have a look at that in a minute. Then this is a so-called inode number, which we will not discuss at all for the moment, just ignore it. Then you have the user who owns the file. I'm the user Aradi on this system. The file belongs to me. That's my file. And then this is the group who owns the file. So basically every file is owned by a user and the group, and those are indicated here. Then we have the size of the file is exactly 0. I mean, this is an empty file. And then we have here the timestamp, the date, and the time for the last modification. So when was this file last time modified? And you see at the moment we are shortly after noon. It's 19th of April. And then you have the file name. Yes, and this thing is this size is in bytes. So usually when you see here a 0 or a non-zero number, is this the size of the file in bytes. You could just, for example, make a subdirectory mkdir sub there, and then make an ls -l, and then next to the subdirectory at least you have also a number. The subdirectory, the subdirectory entry itself is occupying 4 kilobytes. Okay. Now if you want to have a human readable output or human friendly output, then you can also additionally specify the option -h, and then you get the same option as before, with the difference that here, for example, the numbers which were here specify the total number of used bytes, and here the individual file size or entry size. No, they are not written in bytes, but basically abbreviated and with the appropriate prefix. So you see this is 4 kilobytes. So it's usually much easier to read. Otherwise, nothing else really changes. Now we can have a look at the hidden files, the option -a, because basically, as you remember, one of the files but not shown, which we were creating, this file .hidden. So let's say ls -a for all, and then you see that here suddenly we have more files. We have here our .hidden file which we created, and we have also 2 more entries here, dot and dot dot. Or let's us show them in the long format, -a -l. Or those options, those short options, usually you can, if they're starting with 1 dash, you can combine into one option. Minus AL would mean minus A minus S. That's a little bit shorter to type. You get exactly the same. So what do we see here? Here is our dot hidden file. So basically, if you specify the option minus A for ls, you will also see the hidden files. And there are two more hidden files, the dot and the dot dot. And if you remember, dot dot was nothing else. Just when we said cd dot dot, it was leading us up to the directory higher in the hierarchy. So basically, this file entry is the link which links us with the next level of the directory tree, which means with our home directory in this case. And dot is basically the entry which represents of the current directory. So simple dot always means current directory. We can just test it. We could just say cd dot change to the current directory, and you see here in the prompt nothing changed. We are still in the same folder until the /test. Similarly, if we say ls minus l dot, so list the current directory, again it gives us the content of the current directory. And if we say minus al, then it also shows the hidden files, right? That's exactly what we have to know. Notice this ls command has a lot of options, and I definitely not want to show you all of them. But under Unix, usually you have the so-called man command, the manual command. So even if you do not have internet and you cannot search with your favorite search engine, you have a manual under Linux, or under Unix, which is abbreviated with the command man, and then you can give basically the manual, the command you want to look up. And then it starts as a small viewer. So let's try it, man ls, and then it starts a viewer. And in this viewer with page up and page down, you can basically here have a look what kind of options in there, and you see there are tons of options. So basically, if you want, you can have a look at that. If you want to search because you want to look up a certain option which you are using for, let's say, you want to look at the human-friendly format, then let's search for the string human, and this is done with the slash. So basically, in this viewer, if you say /human, then it will basically search for the word human, and indeed, then you get you jump immediately to where it says a human readable format with -- human readable. This is the second form. So basically, for every option, or for many of the options, you have two forms: the short form with -h with 1 dash at the beginning, and the long form with 2 dashes at the beginning, right? So that's also very typical for the Unix commands. Good. And with n, if you hit the button n, you can go for the next search. If you want to go search backwards, so I will go at the end or at just a few pages down, and then I want to search backwards, then it would be basically the question mark, and then question mark human, and it would search backwards. If you want to leave the viewer, it also says here, type Q to quit. So basically just if you type Q, you are back down in the command prompt again. So the manual is something you should be aware of, and now and here on that slide, I just summarize the commands which we just used here. Okay, let's have a look at the file attributes which we discussed. What do we have here? So basically we said ls-l, and then here we have those critical attributes. The first letter indicates if it's a dash, then it's a normal file. If it's a D, it's a directory. And then we have always 3 groups of entries here: first group, second group, and third group. So every group contains 3 entries. And basically X means whether the file, R means whether the file is readable by a certain person, W whether it's writable by a certain person, and X whether it's executable, or if it's a directory, whether one can enter into that directory. And who is the person it refers to? That's very easy. The first block refers to the user who owns the file. So in case that's me. The second one, the second 3 refers to the group who owns the file, which is again me. And the third one basically concerns everybody else who is not the user, who the owner, and also not the group who owns the file. Okay, your username is clear, is the one you type when you enter, when you have to log into the machine. But in which group are you? This is something you can find out with the ID command. If you say ID and minus capital G, and -n for, you can look up in the manual what those options are, but it would show you in which groups you are. And you see me as a user, Aradi, I'm in the group Aradi, so there was a special group created for myself, and then I'm also part of a few more groups. And if any of the files is owned by those groups, and basically here it's written that I can read that file, or that group can read that file, then I would be able to read that file. Okay, so it's quite an easy concept, and that works very, very well. How can you change the file attributes? So for example, let's have a look. We have ls-l, and for whatever reasons we wanted to make sure that the file one.dat cannot be read by anybody else, just by me, by the owner of the file. Then I would like to change those flags. What does it mean? Here I have R and W also for the groups, and R for others, for anybody else, and I would like to remove all those attributes, and even I want to make sure that I cannot delete it by accident. So I even want to remove the write table flag for myself. The command for manipulating those attributes is a change mod command, and basically it's very easy to handle. First you have writing who you want to the write, who is the one for whom you want to change the write. So U would be the user, G would be the group, and O would be others. And let's first make sure that others cannot read the file. Okay, so we say change mode others minus, which means we are revoking some privileges, we are removing some privileges, and we are removing the R, the read attributes for others for the file one.dat. And if you make ls-l, you see that it now changed. So basically here the R flag, which was here before for others, for anybody else, just disappeared. So this file is not readable by others. Now we want to remove the write table flag, and for everybody, also for ourselves. So this is a group change mode, and then we want to remove for the user, which we are, and the group for both of us, the minus, removing the write table flag, W for the file one.dat. And then if you make ls-l, you see that indeed here the write table flag for user and the write table flag for the group vanished. And then finally we want also to remove the readable flag for the group. So change mode minus minus R, G group minus R we want to remove. And then I forgot to specify the file name, which of course you have to do. How can you get back the command back? You just push the arrow upwards, then you get the last command, and then you can just edit it and or extend it, and we let this command act on the file one.dat. And if you say ls-l, or instead ll, which is usually an abbreviation most operating system, most shells have, so ll is an abbreviation for ls-l or ls-la, depending, and then you see that file one.dat, the only access right which we have, that it's readable, and it's only readable by the user because it's the first free one. Okay, so that's it basically. This is how the change mode works. If you want to know more about that, then of course in the manual man change mode you can look up all the possible informations. If you want to, for example, if you can use the user, the group, and the others, but also as A for all as a group if you want to modify something. Okay, good. Let us continue. The last topic which I want to cover is so-called wildcards. What are those wildcards? Those wildcards are if you do not want to type file names, or if you want to let act a command on a lot of files, and we do not want to list them, all of them, but there's a good pattern with which I can define how the name of the files which I want to act on can be defined. And those are the wildcards, and we will just have 4 wildcards which we will use. The star, which means it will match arbitrary characters including nothing. The question mark, which will match one character, exactly one character, and the so-called interval, where I can list a type of characters it can match. We will see in a second examples for all of them. So let me have a look. What do we have here? in this folder. We are still in the test we are still in the test folder. And if I make ls, I have those files, file1 dot, file2 dot, but I want to create a few more. So we would like to create file1, file2, file3, file4, file A, file B, file C, file D. And that, again, this I won't explain the fine details why this works. You can look it up in the bash description. I will just 2, 3, 4, A, B, C, D dot that. I will just basically this construct, which I won't explain here at the moment, it doesn't do anything else, just to creating the file1, file2, file3, file4, file A, file B. So basically creating all the combinations with this item list here. And here before the first comma I have nothing, so it will also create file.dat. But let's make that, and now if I make ls minus l, you will see that I have exactly file 1, 2, 3, 4, A, B, C, and D, and also file.dat. So basically those are the all the things which I have. Okay, and now we want to exercise the wildcards. So let's assume I want to show you all the files which are ending on that, on the string .dat. Then you would say ls star.dat. What does it mean? List me all the files which starts with an arbitrary character, either 0 or many characters, doesn't matter what is the content of those characters, followed by the dot and then the D, A, and T letter. And if you do that, you see exactly only the files which are ending on .dat. For example, you don't see the subdirectory entry because the name of the subdirectory does not end on .dat. Okay. The next thing what I could ask for is, for example, here you see, I also see file.dat. What about if I want to have only things which are starting with file with an arbitrary character, but that must be something, it cannot be the nothing, and then .dat, then I would say ls file (.dat). What does it mean? List me all the files which starts with the word file, then contain exactly one character, and then followed by .dat. And if I do so, you see that I get very similar results as before, but the file.dat is not appearing in the list. Why? Because it does not have an additional character after the word file and before the dot in the file name, before the extension. Okay. Next possibility, what happens if I want to list all the files which are containing after the name file just either 1, 2, 3, or 4. So either the number 1 or the 2 or the 3 or the 4, then I would exactly get those files because they are starting with file, and then the wildcards has been substituted, and 1, 2, 3, or 4 has been listed. I can also specify that as an interval, so I can say 1, 2, 4. And then basically it shows me all the file names which start with file and have something between 1 and 4 and then .dat. Okay. I can also invert it to say show me all the files which do not have the characters 1 and 4 after the file and before the .dat extension. Then basically I can negate it by the bang, and then you see I get all the others but not those which have those numbers here. Okay. And finally, for example, I could use also in that combination the star. I could say, okay, give me all the files, doesn't matter how they start, it can be any arbitrary string, but then at some point before the .dat extension, they have something between A and C, between the characters A and C, so that would be A, B, and C in that case, and indeed, this is showing me those files. So these wildcards are very, very useful to abbreviate commands and to specify patterns which files on which a command should act can be defined. Okay, so then what are missing is some file operations like copying and moving. So basically, if we want to copy files or move files, we can do with the cp and the move commands. The syntax is always the same. You get the source and the destination. The source can it's almost always a file. The destination is, if you're copying a file, can be another file, so it will be copied and created under a new name, Or if you are giving a directory as a specification, then it will copy the file into that directory with the same name as it had before. The same with move. Move means that basically the original file are deleted. Okay, and here you see, for example, if I want to create a file, a copy of a certain file, then in this folder here are my files, and if I say cp file1.dat new file.dat, for example, then it will make a copy of file1.dat and copy it under the name new file.dat in the same directory. Now if I do ls, you see that basically a new file.dat has been created. I could have also copied into the higher level directory, for example file1.dat, and copy it into the directory above into new file.dat. And then I wrote here, okay, go one level higher. So basically copy it in the directory above it. Okay, and then is okay, but of course I should not use ls, but I should use cp. So cp file1.dat /new file.dat, and let's look whether it happened. We will just see with cd dot, we will just go up one level higher and make an ls, and you see also here a file new file.dat has been created. Okay, good. Let's go back to the test folder. We can also copy directories. For example, if we want to copy directory subdir into, let's say, directory subdir1, and then it doesn't work. While cp usually only operates on files. If you want to copy directories, you have to tell it should do it recursively, which means copy the directory and the subdirectory and the subdirectories of this directory. So for example, I would make cp -r subdir, and the name of the new directory should be subdir1. And now it worked, and if you make ls, you see that basically a new directory called subdir1 just appeared, right? And if the directory subdir had some content or some subdirectory, further subdirectories, you would find an exact copy of those also in subdir1. And now to the move command, which is basically renaming, relocating command. For example, if I wanted to rename file1.dat into new file1.dat, then I can do that. And if you make an ls, you see that file1.dat disappeared. So basically we start the list, the alphabetic list starts not with file2.dat, but basically on the other hand, a new file1.dat appeared here, right? So that's it. And you can do the same with directories. So for example, you could, first of all, you could move files into a directory. If I wanted to move, let's say, new file.dat into subdir, which is a directory, okay, it's not unique if I push the tab, but I need subdir, then you see that new file.dat disappeared here. So this original new file.dat is not here anymore. But if you list subdir, you see that new file.dat is there. And you can even rename subdirectories. So basically, if I wanted to rename subdir into subdir2, for example, then you see that now the directory subdir vanished, but instead of that, I have a directory subdir2, and it has, of course, the same content as it had before. So I say ls subdir2, then it has exactly new file.dat in it. Okay, good. So this is basically how you can copy and move files. You can also delete files. Let's delete one of the files here, for example, file c.dat as in the example. So we are saying rm file c.dat, and you hit enter, and it's gone. And now if you say ls, the file is really missing. And therefore, please be very careful. If you delete something, think before you do it, because there's usually no confirmation. We will show a way how to enforce a confirmation before something is deleted. But the default behavior of all Unix shells is usually that the files are deleted without questioning you. So think twice about that before you do something. You can enforce it with the -i interactive option. So let's try to do delete file2.dat, rm -i, like interactive file2.dat, and no, it's asking you. And then you can say either no, then it's not deleting, or you can say yes, and then no, it has really deleted it. Okay, so basically then there is an interactive choice before you do so. Okay, And last but not least, if you want to delete a directory including its content, be very, very careful with that. You can use the -r option. So basically, if I want to say rm-r subdir 2, for example, before then subdir 2. Okay, the file in it was the file in it was write protected, therefore it's asking me. Let's change it. Just push Ctrl+C, Steuerung C on German keyboards to break, to stop this command, stop the execution. Let's go to subdir 2. Let's make an ls-l. We see that it's a read-only file. Let's change the permission, change mode, plus user plus W. So for the user, change the write flag on file, new file.dat. Let's make an ls-l to check whether it was successful. Apparently it was. Now let's go upwards, and now let's repeat the command again. I will just go the up arrow, push the up arrow a few times to go back to the command which I tried already to execute, and then now I hit enter and it's gone. And subdir 2, including the content new file.dat, it's gone. And it's recursive. It's very, very you should be very, very careful with that, because you can delete an entire tree, your home directory fully within a few seconds, and there's basically almost no way to recover. So once you delete something, it's almost impossible to recover. So please, 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 if you use RM, think twice before hitting enter. Okay. The basically kind of last thing as a command we have to handle is creating archives, and the reason for that is because if you make exercises, you want to send it around, you should make an archive of that, or if you download the exercises from the website, it's basically provided in an archive, and then you have to extract it, and this is the so-called tar command. It's the name comes from a tape archive from a very ancient time, and basically it tells you can create an archive with a -c option, and then you say -v for verbosity. We will see an example in a second. -j specifies the compression with the XZ algorithm. It's a very good compression. -f tells you how the file which is created should be called. Those are all the optional arguments. And then at the end, you are specifying the files or the directories to archive. So let's assume we want to send around our test folder. We go our home folder just by typing cd. cd without any arguments takes us into the home folder. Let's have a look with ls. Indeed, we have the test folder here. I will just move new file.dat back into the test folder, because maybe we want to also package that one in our archive. No new file vanished, and it's part of test folder. And now we want to create an archive with a text folder, so we are saying tar -c for creating, -v for verbose, -j, so the archive should be compressed with the XZ algorithm, -f, the archive should be called test.tar.xz, so it's a tar archive with XZ compression, and the only thing I want to compress or include into this archive is a test directory. And then if I hit enter, basically tar shows you on the standard output on the console what kind of entries it was adding to the archive, and you see it is the test folder and all the content of the text folder, including the subdirectory and also including the hidden file. So everything which was in this folder is added. Okay, and that's it basically. And then, for example, if you wanted to download the exercise from the website of the course, so let's just see, we are just trying to hit the link here. It should start the browser with the right, in theory, with the right link. Apparently for some non-obvious reasons it didn't happen, but then we can just do the trick to mark it, hitting Ctrl+C and Ctrl+V, and then going to this page, and don't ask me why it doesn't work at the moment. Apparently for some reason the browser just denied to deny to work. So let's try it again. Maybe the internet connection is at the moment not working, but okay, let's give it one more chance. Now it's better. Okay, so we are here. And then, for example, if you want to download the exercise, you see here the exercise is a PDF document which describes what to do, and then you have the exercise archive. And then if you click on that, you should save the file, not opening, but save the file and say okay. And usually by default, the folder where you have the exercises is the or where you have the downloads is the download folder. And if you go to the downloads folder, you see here is the file exercise01.tar.exe, and it's written red to show you that it's an archive. And then let's do the following. Let's move it out from the downloads folder. So we are going back with CD to the home folder. Then we are moving the downloads / exercise01.tar.exe file to here, to the current folder. You have to specify the destination directory. Dot is the current directory. And then let's investigate what is the content. And if you go back here to the slide with tar, then you see that with the option -t, you can investigate the content. So if you say tar -t, and then you have to say that it was xz compressed, and then -f, the file exercise01.tar.exe. As you have seen, I was using the tab button, the tab key to expand the file name, and you see that it contains a lot of files. Okay, and exactly in this exercise, you have to manipulate those files. Okay, and then if you really want to about testing, it's just showing but not extracting. So that means if you look here, basically the directory didn't change. But if you now want to do the same, but instead of testing, really extracting, and I will specify the -v option so that we see what happens, then it will extract it. And now if you are making an ls, you see that the folder exercise01, as written here, has been created. And if you go to exercise01, you see that there are some subfolders, and then basically the slides on the website here, basically the exercise, that this PDF would tell you what to do with those folders. Okay, good. So far so good. Just a last slide, a quick slide on the navigation. With Control A or Home, Control E and End, you can jump between the end of a line in the shell. So just give you an example, I have this long line here. I want to go to the beginning to change some of the flags. Then Control A, Anfang in German, would bring you at the beginning. Control E, End, would you bring to the end. Okay, and then of course with Control D, or a delete, you can just delete some characters right from the cursor. And and the copy and paste up and down we know already, and copy and paste goes with that letters. If you ever learn Emacs, you will know where these combinations are coming from. Tab key, I told you already, so I will just skip that slide. Use the tab key as much as possible. This is my advice, because it helps you a lot to to spare some typing. And last but not least, the last thing I want to cover is how to edit files. And basically, if you want to become an expert, then you should either look at VI or Emacs. Those are the two very ancient but still developed editors under Unix, which I used a lot. Maybe the entry barrier is not that low, but once you run they're very, very powerful editors. So I really recommend you to choose one of them. I'm usually using Emacs, but also there are many fans of VI, so choose whichever you like more. Here we will use, if we want to edit files, something much easier, some graphical, and the leafpad editor. And if you want to edit a file, you can just type leafpad and the file name. And if you want to make sure that you can after that enter commands, I can show you, then you should use this add character. So let's go to our test folder and let's edit the file new file.dat. So we are called leafpad new file.dat. And if you start this program, then this graphical program starts. Of course, the file was empty, so there is no content. But in the meantime, you cannot type any commands in the shell. But this is not necessary, because the graphical contents should not block the shell. As here, it would be good if you could here type something into the file and at the same time also use this window to type shell commands. So basically, I will now save the content as it is. Yes, I can overwrite it, and then. So, because it was read only, so that won't work. and then I say quit. Yes, no, I don't want to say file quit without changing. Okay, let's have a look. Why didn't the saving work? The saving worked because new file.dat has only the read-only attribute also for us. So we would have to modify it user plus v in order new file.dat in order to make sure it's writable. Now, if we are looking leafpad, if we are loading leafpad, new file.dat, then we should be able to edit it. And then I say with Control S, I'm storing it, and no, or you can say file and save, and no, it has been stored. So basically, no, if I quit it, then it was saved. And the point is, if I do not want to block the command line window during this editing, then I can add an @ sign here. And that means the shell, this thing would start here in the background with the modified content. And here there is some additional information which is written out, but this you don't have to care. But basically, if you go ahead here, you can basically type your comments as usual. One last trick: if you want to clear the window of the command line fencer, you can just push Control and L, the L letter, and then basically with Control L you can just delete it, and then you can type your comment. In the meantime, you can also edit your files. That's very handy if you want to do something, edit here in the content of a file, and then at the same time do something with the file, like execute with Python or something else. Okay. And the file I would like to edit with you today is a special file. It's a hidden file. Okay, let's save. That should work now. It's a hidden file. Let's go to our home folder, and let's make an ls-a-l here. And you see that we have a lot of files which are starting with dot. Those are typically configuration files for various programs. And the one which I'm interested in is so-called bash rc, which is basically the initial file for the bash shell which we are using. And that I would like to edit. So let's say leafpad.bash rc, then add in order to start it in the background. And then basically here you have the content of the file. And I would like to add something at the end. And I would like to add a few comments to make sure that if you delete something, if you overwrite something, there is an interactive question whether you really want to do that. And then this is basically, those are these aliases. Okay. So basically we want to style alias rm is equal rm minus e. If you remember, rm minus e was the interactive one, so it was asking you before deleting something, and basically it says alias means whenever I type rm, the command remove, you should always insert rm minus e instead, and we do the same for the moving. So basically, in case we are renaming something and the renaming process would overwrite something, it should be changed in move minus e, and alias cp, the copying, should change in copy minus e. Okay, and then with Control S, I'm just saving it, and then that's it. So what does it mean? It means let's close this command line window and open a new one. And now basically this shell which I have here should have read in that initialization file which I just did before. And now in theory, if I go in the test folder and I want to just let's say remove file freep.dat, you see that it's asking whether you want to ask it or do it or not. You can either make Control C to stop the process, Control C, then nothing happened, or you are saying yes, delete it. But now before I do Control C, and you see that file free.dat is still there. Okay, so it has not been deleted. But now if I'm doing the same command again, but I say yes, and then I say ls file free.dat vanished. So basically this way, if you edit with bash rc this way, you get some interactive questions, so it's a little bit more difficult to remove everything by accident. If once you want to remove many things at the same time without having to be asked, for example, if I say rm minus r subtier, then it would ask whether you want to go into subtier 1, and if subtier 1 had subdirectories for each subdirectory and each file, it would ask you a question, and that's maybe a little bit a lot. So basically then you can go back to the original meaning of rm without the minus e option, without the alias. if you are writing a backslash at the beginning, right? And then it would basically delete things without asking you, and then it's gone. So basically, no, if you just type rm, it always asks. If you are typing backslash rm, it will go back to the original meaning of rm without asking. And this is something you should consider maybe to add to your .bash rc as well, because it can save your day if you just if it asks you before you delete something which you were not supposed to delete. Okay. And with that, basically, we finished this course. Thanks a lot for your attention. And please go to the exercises which are on the website. So basically here the exercise, the PDF, what to do, and the archive, which we just downloaded. And basically try this exercise, and it will give you a little bit, if you manage to do the exercise, which is not very difficult, then after that you will be quite, you will have the let's say, the necessary skills in order to navigate in Linux, and that should be enough for this course. Thanks a lot for your attention, and I hope to see you in the next session. Take care. Bye-bye.